Hello there, welcome back to Petrophysics Rocks. It's been a while since my last update, about 8 or so weeks or so, possibly a bit longer. And that update was also an update on why it was taking me so long to get my next video uploaded. Well, here I was hoping that I'd get this project all wrapped up by Christmas, and here we are, couple of days before Christmas, and I haven't managed to complete it all yet. I think this update will let you know how far I've got, and hopefully show you some good signs, good progress, and intrigue you to sort of say, okay, I'm going to stick with Graham. I'm going to give him a like and subscribe, because when this thing is finished, it's really going to be good. As you've seen from the thumbnail, I kind of got sucked down an AI rabbit hole, black hole. I've been using AI and ChatGPT to help me develop this spreadsheet idea, this workbook idea further. And the problems with AI are, of course, obviously, it's like you're like a kid in a candy store when you first suggest something, you know, it says, oh, that's a good idea, Graham. Brilliant, fantastic. Because it's very nice to you all the time. And would you like me to do this as well? And would you like me to do that? And then we can do this. And all of a sudden, you're off my normal prevarication and running around different rabbit holes and stuff was accelerated by AI. So it's led me off down the garden path in various routes. And there were some things I didn't really understand about AI when I started, which I'm learning about, which I may put into a separate lessons learned of AI coding. But I guess the main thing is obviously the kid in the candy store thing. You just got to try and stay focused on one thing at a time, because one of the things that AI is not seem to be very good at is having an exact memory of exactly what it said to you 2 responses ago. And it's okay normally in general conversation, but when you're using it for coding help, and I've not really done any coding before, as I say, I've spent my whole career avoiding VBA and macros. I've tended not to like them. IT departments don't like macro-enabled spreadsheets either, which is a bit of an issue. So I'm trying to keep that to a minimum. But we'll see how that develops. But I've been trying to avoid it, and one of the issues with AI is it gives you some code, and that's great. And of course, when you want to update it or tweak it, it doesn't quite work. You adjust it. It can't really remember the exact code that it gave you 3 responses ago, and so therefore, I learnt to my cost that you have to keep reiterating and going back and cutting and pasting the exact code that it gave you 3 responses ago, so that you can help you debug the code. That was a really valuable lesson. That's probably 3 days worth of work that I realized that actually it starts everything from first principles with every response it makes you. I learned about ChatGPT projects, which are excellent actually, and you should definitely find out about those. I've created a project for this spreadsheet, for this workbook project, and therefore it does know things from one chat stream to another. So we have a little chat on coding, presentation, you know, various elements of the project, and because it's within one project, it can refer to itself. But basically, anything longer than 300 lines of VBA code, it can't really hold in a memory. And as the longer you go on with these chats, the slower they get, the more laggy, and you have to start a new branch, as it were, and you have a handover. And anyway, as I say, I might do a separate video on that, because it's quite interesting how long it takes, and in many ways, Petrophysics (PP) is often, in this case, a pensioner's pursuit, because it's only retired old guys like me and girls like me that have time to iterate through and get to a final solution with AI, because it's not quite commercial yet, I don't think. I think I can see that maybe this time next year, when it can hold a little bit more memory, a little bit more stuff in its RAM, that then it can have a conversation with you and you can work out exactly what's going on. But at the moment, it's just not quite there, it seems. So anyway, that's my excuse. We're nearly at Christmas. I'm pretty busy in January doing something, so I possibly won't get back to this until February. But please don't unsubscribe or whatever. In fact, subscribe and comment down below if any suggestions you have. You'll see from the update the direction that I'm heading in, the extra functionality that I've added and plan to add, and hopefully you'll find that useful. It's all really in aid of the Aberdeen Royal Infirmary Children's Hospital. I've been fundraising for them for a long time now, and I thought I'll put this workbook together and distribute it to you guys freely in exchange for a contribution to the Archie Foundation. I'm going to use the tool in my teaching. I'm trying to put together a Petrophysics course, and I'm going to use this suite of tools to help teach that course and I'm using Excel because it's kind of like the lowest common denominator, and obviously not everybody has access to specialist log analysis software. But hopefully you'll be able to play with this and see what you think. So it's all in aid of Archie Children's Hospital. Please like and subscribe, make a comment down below, and I wish you all a happy new year. I hope 2025 was good for you too. I got quite a lot done, obviously not including this lack of productivity on the videos, but 2025 was a great year for me, my first year of retirement. It's been fun so far, and I hope to continue it next year. Have a Merry Christmas and have a Happy New Year, and I hope you have a great time in 2026. Okay, cheers then. Thanks a lot. Bye. Hello there. Welcome back to Petrophysics Rocks, and this is an update on where I've got to with my GDPC Petrophysical Maker Suite, as I'm calling it these days. I'm putting together this standalone package, self-contained modeling suite, which consists of, at the moment, four spreadsheets. We've got the EARTHmaker, which was the subject of my last video, which you can go back and check out the beginnings of that. I've got the LOGmaker, which runs logs in this Earth model, creates pseudo logs. I've made some progress there. Then we're going to go and have the look at the CPImaker, which is the analysis part. We take these log data and we analyze them with standard petrophysical techniques. And I'm interested to know how close we can get back to the original input Earth model that we made with these techniques. And then the kind of cherry on the top is the FlowMaker, basically taking this interpretation and indeed the EARTHmaker interpretation and seeing what it would flow hydrocarbons, both oil and gas, and also water. And we'll see how the modeled results compared to the original input results. So that's what I'm adding in. There's potential for another standalone spreadsheet called CoreMaker, which will take the core data from the Earth model, bring it back to surface. Everything relaxes, dilates, gets a little bit looser, and we have the difference between the core properties, the Earth properties at surface, having been recovered by the drilling process, and then therefore we can have a look at reverse engineering to get it back to in situ liquid conditions, in situ overburden conditions, and then also I might add on a STOICmaker at the end for looking at sensitivities on how to calculate hydrocarbon volumes in oil fields and gas fields, and obviously I want to use this as basically the tool for my training course. And if we've got 8 participants in the training course, we'll have 8 different wells drilled into the Earth model, 8 different realizations, if you like. And then we'll get 8 different sets of logs everybody will analyze their logs independently, and we'll see what we can do in terms of averaging. How many wells do we need to average to get back to the truth, and how far off is our interpretation, sort of stuff. So that's where it's all coming from, and I want to put this all together and distribute it freely-ish in aid of the Archie, the Aberdeen Royal Infirmary Children's Hospital, the Archie Foundation. I haven't decided exactly on the exact monetary model. I'm putting a lot of effort into this, so I'm hoping that people would like to contribute and make a contribution to the Archie, my Just Giving page, and then in return for that, I'll send you this suite of logs, the suite of Excel spreadsheets as and when they kind of develop. Now, so overall, here's a little bit more detail of what I'm hoping to achieve in these models. As I said, I've got the EARTHmaker, which is the source of all truth, which we put down there, and we say these are the properties we want to model, and it creates that Earth model. Then we go and make the logs with our LOGmaker. We log realistically in downhole conditions, create a set of logs to work with, and then we'll analyze those logs in the CPImaker, and then we'll see how things flow. You can maybe pause the screen if you want to read a little bit more detail about what I'm trying to achieve with each spreadsheet. And that's as far as I've got with the introduction stuff. So let's go back to the main event, the current version of the spreadsheet. Here's EARTHmaker, which you saw in the last presentation, my last YouTube video. It's still here. I've slickened it up a little bit. I've put in some depth increments in here to round things off to the nearest bed increment, and there's a facility here to make it at a higher resolution. So at some point down the line, we can check out making a high resolution Earth model, say at 0.1 of a foot, and then we can play around with logging that with our standard tools, and we'll see how much information we lose when we go to LOGmaker. But for now, you've seen EARTHmaker before. I refer you back to my previous video, and here's 4 beds, the fourth one just off the bottom of the screen here. We've got 4 beds, 10 foot thick, and we can play around with this. As I've said, I've made it a little bit more robust. So if we change that to say let's have 4 beds of 2 beds, 2 foot thick. Takes a little while for the screen to refresh because I'm recording the screen as well, so that kind of slows things down a little bit. So we've got 2 foot beds thick, 2 foot beds now. Let's increase the number to 6 beds. You can see how this works. We've got 6 beds of 2 foot thick. Let's increase it further to no, better not replace that. Let's increase it further to excuse me, 8 beds. So therefore we've got 8 beds at 2 foot thick, but that's probably not so great. So let's make these beds 4 foot thick. Somebody in the class, obviously, if I run this course, I may well give them an interchannel area, and we may say, right, you've got the thin bed problem, and somebody's got the lucky 5 foot thick beds or whatever. But that's the sort of thing we do. So we saw that last time, and as we mentioned before, we can add in a little bit of stochastic noise or structural noise to this. So you can see I've got all the beds are 4 foot thick, but if I just toggle this onto 1, then on average the beds are now 3.94 foot thick, but they range from 1 foot thick to 8 foot thick to 5 foot thick. So I've got a variable bed thickness, and I've added in an extra fascies as well. Basically, I've said any thin beds below the bottom 30% of thicknesses, I'm going to call that fascies 2. So bear that in mind. We've got two rock types, which at the moment I'm controlling on bed thickness. So the thinner beds are going to get allocated a different fascies, and we can change that criteria. And as I say, we can just press F9, and you'll get different realizations of the bed thickness and your models or whatever. And when you see one that you like, I'm going to put a mechanism in here to sort of capture capture that. So that's just changing the structural noise, if you like. So there's a realization. Now we saw last time as well that obviously it's not just structural noise in here. There's geological noise. So obviously I've got properties to put in this rock, and I've got a couple of J functions to populate a saturation with, and I've got two J functions. I've got, as I mentioned, two different facies. I've got a good facies and a bad facies. Good sand, bad sand. Here you can see that in the good facies the saturations are a lot higher, lower down, and here the poorer facies is a bit lazier. Anyway, when I finally finish this, I'll obviously put out a video to explain each of the spreadsheets in a little bit more detail. So I've got these J functions, and they're derived from poorer perm relationships, and I've got a net cut off and stuff like that, but I can add in a little bit of geological noise. So I just type in 1 to toggle the noise on, and there you see this is just geological noise. Now what I'm going to do is I'm going to add tool noise and logging noise in the next spreadsheet as well, sort of stuff. So we'll separate out what's geological variance and what's down to statistical tool measurements and stuff like that. And then hopefully at the end of the day we can try and deconvolve and work out in the real world, would we know what's affecting what. Anyway, so this is the geological noise, and as I said, you can press the F9, and now we've got the logs varying. This is just, as I say, 50-footer logs just to get the maths up and running, and there may be a few algebraic errors in it at the moment. As I say, it's still work in progress, but basically I've got two sand trends here, a good sand and a bad sand. Not much of it, it's a bad sand, and I've also put in a little bit of a shale trend, which is at the moment just happens to be 10% of the poor sand facies here. And so you can see in these shales the predicted permeability. So that's where we were at last time. As I say, I made it a little bit more robust and a bit friendlier, and this is kind of what's taking some time. So if we go to the LOGmaker spreadsheet, there's the LOGmaker spreadsheet, and in this one I've got some details of a well that we're going to drill. So these are the various hole sections and mud parameters that we've got. And if we go to the LOGmaker logs, I've got an invasion model here, basically taking these mud properties and that geological realization, basically plotting the invasion profile away from the wellbore. So here the green is the original hydrocarbon in place, and the blue is the invaded zone according to my model. And here at the top is the tool investigation radius. I've done a little bit more. That's basically what's taken me all this time. Last time around, I think I was making logs with a simple 1-to-1 average, but now I'm starting to model the borehole environment a little bit more scientifically, if you like. I'm not saying it's right, but it's basically using my geological realization. And basically, each one of these tools has a different depth of investigation and responds obviously as you log these tools over this. I'll just take my cursor. If I excuse me, let me just go back here. There we go. If you log each of these tools over this invaded profile, you'll see that each tool responds differently to the profile. I'm hoping that I build up the logs, and obviously at the moment this is all linked all the way through the spreadsheet. So as I press the F9 button, okay, they all momentarily blank out there or whatever. But as you can see, with every different realization, I get a different invasion profile. And when I've got this working appropriately, I've got there's something in there. I'll promise I'll make it more robust. Every now and again a realization triggers a number that upsets it or whatever. So that's the different realizations in the invasion profiles. We'll record logs over that, and then we'll put them into the CPImaker spreadsheet, which which has a series of traditional inputs of petrophysical constants, which I will teach you all about on my course, and how to do the log analysis using these courses. Let me just I'll tell you what I'll do. I'll just zoom this into 75% so that you can see a little bit more of the data. So these are the petrophysical constants for the neutron tool: density neutron, compressional sonic, shear sonic, mud parameters, Archie parameters, etc., temperature, pressure, routines. This is the input parameters, and you'll see here also that I've got some, as I mentioned before, I've got some slidey bars, I've got some statistical noise, so hopefully we'll be able to do a full Monte Carlo analysis at the end of the day. And also I've got some slidey bars here so that you can see as you vary the parameters, I'll teach you about the variation that it has, the impact that it has on the CPI log. So here is the CPI of this particular realization. If I compare it to the EARTHmaker log, that's the Earth logs at the moment, and this is the CPI. This is still using my dodgy filters at the moment. I haven't quite got it using the real logs at the moment, so this is just a smooth version. So I'm cheating a little bit for the purposes of this demonstration, but hopefully you'll see that we'll be able to sort of toggle between the EARTHmaker logs and the CPI interpretation. And if I press F9 again, you can see the realizations change as we've shown. All of these spreadsheets are linked all the way through at the moment. I'm hoping that I may be able to distribute them separately as well, if appropriate, but we can toggle between the CPImaker and the EARTHmaker and see the difference in realizations and understand the errors that we're making or introducing through our analysis process. Okay, so if I just do an F9 there, just for, we get another realization up. Oh, get a good realization. That would be good. I will fix that. I'll find out what's causing that, and then we can toggle between the two, and you can see the difference there. As I say, in each spreadsheet there is a handy dandy link to my Just Giving page at the Archie Foundation, Aberdeen Royal Children's Hospital in Aberdeen, and you can make a contribution there. I haven't exactly decided what the monetary model will be. As I say, my idea is that these spreadsheets are all potentially standalone, so you could just get the one, or you could get the whole suite for a bigger contribution. I haven't worked out the exact monetary model. Perhaps you could indicate in the comments down below. What do you think it'd be worth? I'm putting a lot of effort into it, so hopefully that will be reflected in some of the contributions. Of course, my contribution guidance will be just that, a guidance. If you want to put more in, then that will be fine. But maybe you might want to try one spreadsheet out first for a smaller amount, and then if you want to have the whole suite all linked together, which will be the most fun, obviously, you can make a small upgrade. I'll figure out the details at some point, but probably not going to get back to this now until February time, I guess. Once I've sorted out all the stuff that I have to do in January, but hopefully that's given you an idea of where we stand with this beast at the moment. Okay, actually there is just one more thing I should mention. I'm trying to keep the amount of macros and VBA to a minimum in actual day-to-day use. Everything you've seen so far has just been using native Excel functionality. Where the VBA comes in is if you want to import data of your own into the raw log display. So, example, if you had some raw logs that you wanted to put in of your own and analyze those using these tools. One of the things that I do is make extensive use of range names. So therefore, if you interpret your data, the basic premise will be that you scan that with a macro. Say, okay, where is your data? what part of the spreadsheet is it on, identify the regions, and say, okay, where are you going to get your density log from, where are you going to get your gamma ray log from, and then it will create some named ranges. I'll run a separate spreadsheet to create the named ranges so that they match mine or whatever the input logs. I say, okay, you've got a gamma ray here, and we're going to call that whatever it is, C gamma ray, and then the equations in the spreadsheets all use English. Basically, you can have a look here, and hopefully it's a little bit more user-friendly because I'm using named equations. Then you can see, rather than an impenetrable bunch of cell references, I'm using these range names. And you could go through and do it all manually once you understand the concept or whatever, but I will create some macros that take the ranges and name them in Name Manager. If I go into formulas, define names, Name Manager, let's have a look here. You can see that there are a bunch of named ranges. Now, each range has its has a prefix depending on what spreadsheet it's in. So all the E underscore ones are prefixed from the Earth spreadsheet, the EARTHmaker spreadsheet. All of the F ones are from the FlowMaker spreadsheet. All of the K ones, well, they're from the they're from the LOGmaker spreadsheet. They're the kernels, but here's the L ones from the LOGmaker sheet. So there's method to my madness basically, but you can see all the range names here, and obviously that is a bit of a tedious thing to do manually to create all those names. So that will be the macro. And I know that IT departments around the globe don't like you having macro-enabled spreadsheets, as I've said, but I'll try and keep that to a minimum. You may have to use it on your home PCs yourselves. Okay, that's it. That's the current status. As I say, like and subscribe, and you'll be the first to hear when this beast finally makes beta testing. If you'd like to be involved in some of that testing, then get in touch with me and we can maybe trial a few things out first up before it goes on general release. As I say, I'm just trying to use this as a tool for my teaching course, but at the same time, if I can raise a bit of money for the Archie Foundation, the Aberdeen Royal Children's Hospital, that seems a sensible thing to do as well. So that's all I'll be asking for this. If you'd like a copy, like and subscribe, and drop me an email, and I'll keep you updated as best I can. Hope 2025 was good for you, and I hope 2026 will be even better for you. Merry Christmas and a Happy New Year. Cheers. Thanks a lot. Bye now.